Module 6. It's about Etherchannel. Okay. So the main objective is just troubleshoot Etherchannel on switched link. So the areas that you're going to go through have Etherchannel operations, then configure Etherchannel, then verify and troubleshoot Etherchannels. So the operations, there are scenarios in which more bandwidth is or redundancy between the redundancy, it's what we covered last time, between devices is needed. The scenario when we need more bandwidth, redundancy, we need more bandwidth and then redundancy. But last time session, it actually proved, or it showed us that the redundant links, they're supposed to be blocked to prevent loops on a switched network. But with Etherchannel mechanism, or the link aggregation, because link aggregation is combining multiple links. So multiple links could be connected between devices to increase. But still, in this scenario, when you have multiple, for example, between switch 1 and switch 2, then automatically 2 of the links, they are going to be blocked, and then it's one that is going to be allowed to forward. So a link aggregation technology is needed that allows redundant link between devices that will not be blocked by STP. That with this link aggregation technology, it will allow all the 3 links to be active and in forwarding state. So Etherchannel technology makes it possible to combine the number of physical links between switches to increase the overall speed. So once you these links are allowed to be combined, then automatically the speed which is going to change from 10. Of course, physically, this it has 100, even this 100, and then this 100. But there is a logical link. Now that logical link, it's going to have a speed of 300 MB per second. So there we will have increased the bandwidth. So Etherchannel here as the technology or the mechanism was originally developed by Cisco as a LAN switch-to-switch technique. Switch-to-switch technique, not a switch to PC. Grouping several fast Ethernet or gigabit Ethernet. And as we are doing this, you can't combine gigabit and then fast Ethernet. This is not allowed. It has to be gigabit and gigabit fast Ethernet with fast Ethernet, so that you get a logical link. So when Etherchannel is configured, the resulting virtual interface is called port channel. That once the ports are combined, this and this, then you end up getting what you call port channel. So the logical link is called a port channel. So when you look at this, without Etherchannel, without link aggregation, then automatically one of the link here, it has to be blocked, even here, to prevent redundancy. But now that they are grouped, they will be treated as a single logical link. So advantages of Etherchannels. Most configuration tasks can be done on the Etherchannel interface instead of each. But if you have like 4 and they are grouped, of course, you will actually get a single logical link. Logical link. So all the configuration that you prefer to have under all these interfaces, they can be done under the single logical interface. So this one here actually it improves the efficiency, the consistency, consistency of the configurations on all the interfaces to have uniform configuration. Not you have this on fast Ethernet and then the other one that you've forgotten this, maybe you've used a different parameter on that. So Etherchannel relies on existing switch ports. So if your switch has fast Ethernet, you're going to deal with fast Ethernet. You're not going to force it to have gigabit Ethernet. Load balancing takes place. Load balancing, it takes place between the links that are part of the same Etherchannel. Once you group all this, then it means that whatever packet that is being sent, for example, let's assume that we have packet 1, 2, 3. So packet 1 can check this, packet 2 it can go through this, packet 3 it can go through this, then packet 4 maybe through this. Load balancing. But if you don't have the Etherchannel or the link aggregation on between your switches, and you have this, then automatically this is going to be blocked and this, so that all the 4 packets go through a single, and then these other ones, they will be added into a pre in case, let's say, the primary goes down. So Etherchannel creates an aggregation that is seen as one logical link. All the 4 physical, they will be treated as a single logical link. So STP may block one of the bundle to prevent switching groups. When the STP blocks one of the redundant links, it blocks the entire this. So there are those scenarios. For example, let's assume I have my switch here and then another switch. So then the Etherchannel, I have 2 of them, like this. Now, this is this and then this. Now automatically here you have the redundant link. Because we have our logical link here separate from this one here. Now the redundant link, it has to be blocked. And if this logical link is to be blocked, then automatically the physical link that actually that are contained within this logical link, all of them, they are going to be blocked. They will be blocked. Then Etherchannel provides redundancy because the overload link is seen as one logical connection. Additionally, the loss of one physical link within the channel does not create change in the topology. For example, where we have this, there are 4, and then maybe one of the link is down. Yes, this one here is going to be down, and the only effect is that it's going to reduce on the the bandwidth, but the connection is going to stay. It's going to stay because we still have 3 of them and they are active. So this one here, it's going to fall out. So I can give an example. It's like, you guys, I don't know whether you've already started grouping yourselves and like you help each other. Maybe like weekly, you keep 10K, maybe 5K, and then next time, in case someone have issues and blah blah, you contribute. You get it? So with time, if you start maybe you're like 10, there is a possibility like maybe 1 or 2 they are going to fall off. Are they going to stop the purpose of the group? The group, it continues. If you can't manage, be aside. Or you can even add on the number from 10 maybe to 15. You get it? But still, it's not going to change anyway. So implementation restrictions, what you actually, the restrictions, what you're not supposed to do. If you do it, then automatically you're going to have problems. Interface types cannot be mixed. I already explained that, and they are here. You cannot mix fast Ethernet with gigabit Ethernet. Make sure that they are the same. It's fast Ethernet with fast Ethernet, gigabit with gigabit. Okay. Then currently each Ether channel can consist up to eight each Ether channel. So each group, the logical group, it should not actually, the physical ports, they should not go beyond 8 ports. So as you grouping, maybe maximum physical ports that you can have in a group, they're supposed to be 8. Then per switch, the groups that you can have on a switch, they're supposed to be 6. So if we have 24 ports and you decide to group 2, then it means that you're going to have 6 groups, meaning that you will group only 12 ports. Now here we're in terms of the number of groups that you can have, okay? But when it comes to the physical ports that you can have in per group, they're supposed to be 8. So meaning that if you have 24, you can move and you have to distribute it equally. 8, you'll have 3 groups. Three groups on a switch. Because here you have 8, then 8. Okay? But if you want more, then now it means that you have to reduce on the number of ports per group. But now if you reduce on them, now look at the number of groups that we need on a switch. They should not exceed 6. So you have to play around with that. The number of ports per group, they should not exceed 8. The number of groups per a switch, they should not exceed 6, period. Cisco Catalyst switch layer, which currently supports up to 6 Ether channels. Yes, please. In the configurations, please, you have to make sure that all the settings, the configuration, they are consistent. Maintain the consistency on the both ends, this side and then the other side. Additional ports on each channel must be configured as layer 2 ports. So if you are to deal with those Ether channel, make sure that those ports are configured as layer 2. Because there are those scenarios where you will be dealing with layer 3. And the layer 3 port, it can actually function as a layer 2 port at the same time as layer 3. So once you convert it to layer 3, then automatically it will request you to put the IP address. But the layer 2, we don't need the IP address. And in case, let's say the port it has an IP address, don't waste your time. Even if it's layer 3 and it has an IP address, do not try to aggregate. Because you cannot combine IP address that .1 and .2 together. No, they will not. So each Ether channel has a logical port channel interface. Every time you group those ports, so whether they are 7 or 8, 5, 2, 3, then automatically you will get, or it's going to be assigned with a logical interface. The one that you will actually be dealing with to affect these other physical ports that are part of the logical group. That if you combine 4 of them, then automatically there should be a logical interface. Maybe port channel 1, port channel 2, something like that. Then we have auto negotiation protocol. So Ether channel can be formed through negotiations using one of the 2 protocols. We have port aggregation protocol, whereby you can abbreviate it as PAgP, port aggregation protocol, or link aggregation control protocol. Maybe you can call it LACP. So these protocols are allows ports with similar characteristics. So if they are not similar or with not the same characteristics, then please, it's not going to work. Note, it's also possible to configure a static or what we call unconditional Ether channel without PAgP or LACP. In other words, you force it. But there are other conditions where they will have to negotiate. So if we start with the PAG operation, So as you can see, it is pronounced as PAng, then space P. It is a Cisco proprietary protocol that aids in automatic creation of Etherchannel link. When an Etherchannel link is configured using PAgP, packets are sent between Etherchannel capable ports to negotiate the forming of Etherchannel. So when enabled, PAgP also manages the Etherchannel. The packets are sent every 30 seconds, checks for configuration consistency, and manages link additions, and failures between the two switches. It ensures that when Etherchannel is created, all ports have the same type of configuration. All configuration. So every 30, once it's configured, every 30 seconds, it keeps on updating because it's point to point. They keep on exchanging the messages. And that information, it's for checking the consistency. The consistency. So the operations or the modes, in case, let's say you do have the PAgP, we have 3 modes: on, PAng, then desirable, and then auto. The moment you use on and on, that is static, non-negotiation mode. It's immediately, there is no, it's like you knocking on the door. So when you knock, you initiate, you're trying to negotiate. Am I allowed? But with on, if the other side is on and then the other side is on, it's a must. It's like when they tell you, because some of you are told, please go to Makerere and do CCNA. You have no choice. That is on static. Whether you want or not, and they're actually following you. They keep calling some of us. Hey, is my boy there? Yes. He attends the exams, he attempts exams, blah, blah. Yes, that is on. Then we have desirable and auto. The desirable and auto, those ones, they have to negotiate. But it can't be auto and auto. I'm trying to summarize this so that you read on your own. With desirable and desirable, the desirable option, it initiates. It's like knocking. Are you there? Am I allowed to enter the desirable? So while the desirable option, it initiates, it's the initiation of the Etherchannel the establishment. But the auto, that one, it doesn't. So the combination of the dynamic, it has to be desirable, auto. But auto and auto, it won't. Auto and auto, it won't. It's not going to work. So it's still the same case. It's still the same case when it comes to the other LACP. So with LACP, we have on, as you can see. So the on, it cuts across. See? It's within LACP and then the other one. But you should not consider it as the mode 4. Because now, if we have on, and then this is LACP, you have on, and still it is under what? PAgP. How are you going to differentiate that this is LACP and this is PAng? Is there a way? Because we have on up, and even here we have on. So meaning that this one here, it's for establishing Etherchannel, but it is not attached to any protocol. How do you get? Because it is under on, it is under PAgP that you can use on. And even when it comes to this, we have on and then on under LACP, meaning that if you have the Etherchannel formulated, established with on, you will not change. Either it's LACP or PAgP. Are we together? You won't change. chain, because in the previous we have it, as you can see, that we have on, and then even here we have it there. So you won't tell that it's under this or there. But for us, for it, what it's going to do, just to give you the grouping, see, the Etherchannel formulated. Yeah? It's formulated. So within this one here, we have active and then passive. Active, passive. Still, still the functional is the same. But for this one here, it is neutral. It is neutral. It is actually vendor neutral. It is not attached to Cisco devices. So it cuts across. It cuts across. So we have active and then passive. So if you're to, if the Ether channels are to be established, the combination still this, but this one here, please, it's general, it cuts across, even in the previous, and you cannot have on either passive or active. That one it's off, but you can have active, because the active side, it initiates the, it's possible it can initiate the negotiation, and then we can actually have active and passive, then passive, active, but passive, no way, no way. And another thing, the passive here, for it, it's just to receive the initiation from the active side or from active end. So configure Etherchannel. The guidelines. Etherchannel support. All Ethernet interface must support Etherchannel with no requirement that interface be physically contiguous. So as you're grouping, you don't need to use the range. That's from port 1 maybe to port 4. You can pick port 1, port 10, port 20. You group them. Okay? You group them. Speed and duplex, they have to be the same. So if port 1 is maybe set to 100 MB per second, even the other port, it should be 100. That brings in the ports now. Gigabit Ethernet, it can't be grouped with fast Ethernet. But if it's gigabit Ethernet and gigabit Ethernet, still make sure that if you change the speed to 100, change all of them. If maybe it's 1 GB, make sure all of them are GB. Then range of VLANs. Now with range of VLANs, here what they mean, like allowed, the allowed VLANs. Because there are those scenarios where you'll have to, because it's point to point, switch 1 here, switch 2. And you have VLAN 10, 20, and you're allowing 10. So even when it comes to this end, you have VLAN 10 and 20, allow 10. This time do not allow 20. Because if you allow 20, then expect a mismatch. Okay? Expect mismatch. The scenario point on this where we have VLAN mismatch, because you cannot now if you to go to VLAN match, then that is when you're using what you call the legacy inter-VLAN, something like that. Legacy extension of the VLAN. You're extending VLANs on switch 1 and then the other side. Where you have to pick some cables in this VLAN and then in the other. But that is legacy method. I don't need to go all that far. So we've talked about this these guidelines, that the speed, if it's 1 GB, let it be on both ends, duplex full, and then VLAN, something of that sort. Now, configuring LACP configuration example, there are steps that we need to go through. This I will not do, but I will give you activity and I say whether you get it right. Of course, it marks you. It's not me who is going to mark. So step number 1, specify the interfaces. As not clear, but specifying the interface. You call the interface. I want to deal with this interface. You can call one at a time, but if you use one at a time, you're going to have issues. See? For example, here we have the range. You can call the range interface from 1, as you can see, from 1 to 2. And then after that, it is advisable to first shut them down. You get it? Shut them down and do the settings that you want to do, and then bring it up. But still, if it's not part of the network, you can, if it's just a local network, you have your switches here and blah, blah, you can go on. But if it's part of the network, you're working on the switch that is on the function network, then you advise first switch off those ports, disable them. So channel group, as you can see here, we are grouping channel group, then mode. Here, this is why you state the channel group, and that channel group actually it ranges from 1 up to 6, the total number of groups that are allowed on the switch. Okay, so it's 1 up to 6. Now here we have 1 it is taken. So as you record it, you can say 1, 2, 3, 4. It will not allow you to, and even in arranging code, you're not going to give it 8, because maybe you have to, and then you start with ID 8. It won't. The range is from 1 up to 6, meaning that is the limit. Okay, so after that, once you state this, the channel group this active. Okay, now our port channel 1, it is created. So if you want to deal with these 2 ports, you will deal with the logical port, which is this interface port channel 1, and then you do the configurations that you want to add there. As you can see, switch port mode trunk, then switch port trunk allowed VLANs. You see 1, 2, 3. It's under the logical link that was created, not under port 1, port 2. Those are physical. But now here we have the logical. Whatever that you said under the logical, it affects all the physical interfaces that are part of that logical that port channel. So this is configure Etherchannel basic switch set, where you complete the following basic switch settings: Etherchannel with Cisco PAng, then configure Etherchannel, redundant Etherchannel links. So verifying and troubleshooting Etherchannel. If you want to troubleshoot, what we're going to do to run, get used with these commands. The shows. It's not like in your operating system of the computer. Hey, my computer, it is slow. You click here, click there, click. Okay. So here, instead of clicking here, there, this, you have to use the show command. See? Are my interfaces up? Show interfaces brief. This show get used. And how are you going to get used? Not by reading. Because some of you are like, I have slides, let me read. So you reading this, what is it going to add you? Show blah blah. You've not even, you get it. But after you configure whatever that you configure, go back now, use this. Show Etherchannel, blah blah. After configuring all that. So we have show interfaces port channel, show Etherchannel summary, show Etherchannel port channel, show interface Etherchannel. All this with the descriptions there. So common issues with Etherchannels, things that you need to, in case let's say you're not getting expected results, what you need to check as you troubleshooting. Assigned ports in Etherchannels are not part of the same VLAN. But this one here, I don't want to go deep with it because that is legacy. Legacy, the way of the connection. That you're looping VLAN per VLAN. You have 2 VLANs. You want to extend them. Now you're connecting VLAN 10 to VLAN 10, VLAN 20 to VLAN 20. That is a legacy method. You don't need to go, but it should be to your mind. Trunking was configured on some of ports that make up Etherchannel. but not all of them. That is if you deal with port by port. Like we have groups and then call group 1 and then start calling Isa, please go do this. What's your name? Mary? Wait, yes, Gloria. Come go do this. You see that? That in actually giving you tasks or assignment in that mode, I'm likely to give you more tasks than the other one. And yet you're supposed to do the same task. So if you're in group, I will say group 1, please. You have to do this. Whoever belongs to group 1. So the tasks are cuts across. That is that point. Then if allowed range of VLAN is not the same, is not the same, I'm allowing you, please exit the building. And then when you reach at the entrance as you're trying to exit, they're like, hey, please, where is the clearance? Shit, you go first, go back. But me, I allowed you. First, go back. And you say that. You're allowed, but the other side, you're not allowed. You're not allowed. So the dynamic negotiation option for PAng and LAC are not compatible, configured on both ends. I expect this and more, even more when it comes to the exams, you'll face that. That the other side you have on, and then the other side you have desirable, or you have passive. It's not going to work. This side you have passive, even the other side you have passive. The modes are not compatible. You have auto, and then auto, the other side, they are not compatible. So we have a ticket here. In the figure, interface 1, 2 on switch 1 and 2 are connected with Etherchannel. However, the Etherchannel is not operational. So if it's not operational, what are we going to do? Now our commands, the verifying commands, the shows, they come into play. View Etherchannel summary information, and the command it's there, though it's not clear. Show Etherchannel summary, and then you look at what we have here, that the Etherchannel is here, but the state is down. The port here is down, and even this one here is down. What could be the problem? You verified that the ports are, our channel is down, it's not operational. Now we need to find out what could be the problem. Step number 2, view the port channel configurations. We need to look to go through what we, let's assume that we are the ones who configured that topology. Now we need to check and see what did we configure. So still it's not clear, but when you look at the show run, the interface, we have interface port channel 1, switch port trunk allowed VLAN 1, 2, 20. The mode is track. Then the ports that constitutes within the port channel, we have port 1 and then port 2. The allowed VLANs, they are the same, 1, 2, 20. The mode is strong. But when it comes to channel grouping, the mode is on. The mode is on. Now that is on, what do we expect for it to operate? What do we expect to the other side? It has to be on. That is what we're expecting on the other switch. So if you find that it's a different mode, then automatically that will be the problem. So when it comes to port 2 still, which is under port channel 1, the allowed VLANs, they're the same 1, 2, 20, and then the mode it's trunk, and then the port channel, channel group 1 mode it's on, meaning that the configuration is consistent on that. Then when it comes to switch 2, the allowed VLANs are still, we have 1, 2, 20, which is okay. The mode it's trunk, and then ports still, when it comes under port, we have allowed VLAN 1, 2, 20, okay. The mode it's trunk. Then the channel group 1 mode it is desirable. Automatically that is the problem. We cannot have on and then desirable. But you can have desirable, or on. But most of the time, if you asked If you're asked the mod to create ether channel without negotiation, then use your own on. It's you're dictating, you're commanding, you're commanding the ether channel to happen. But when it comes to the negotiation that you want the two switches to negotiate, then now you go for those either LAC, but still you will be asked choice, is it LAC or it's span? So here, if we are to rectify this, what do we need to do? Because we're not going to use static, meaning that if you are to change, we should not put on, no, because we need those protocols, those mechanisms. So we have to go for desirable or auto. Okay. So step number 3 here, it's collect the misconfigurations. Of course, you have to go back on switch 1, and then you make sure that the mode, this time it is desirable. And then step number 4, you verify again, show ether channel summary. Now this time, the state is up, and the protocol, when it comes to the port, they indicates that the ports, they are bundled, they are grouped. They are grouped. So that is